Hello friends, my name is Ruskahang Limbu, 4th semester physics from Namti Government College, Kambrang, and I am going to discuss on the topic length contraction and time dilation, which is our second seasonal exam under Sikkim University, which is given by Dr. C.P. Khatriwala. Let's start with the history of length contraction. So length contraction was postulated by George Peters in 1889 and Hendrik Anthony Lorentz in 1892 to explain the negative outcomes of the Michelson-Morley experiment and to rescue the hypothesis of the stationary ether, Lorentz-Peters contraction hypothesis. Although both the Peters and the Lorentz alluded to the fact that the electrostatic fields in the motions were demonstrated, it was considered an ad hoc hypothesis because at this time there was no sufficient reason to assume that the intermolecular force behaved the same way as electromagnetic one. In 1897, Joseph Larmor developed a model in which all the forces are considered to be of electromagnetic origin, and the length contraction appeared to be a direct consequence of this model. Yet, it was shown by the Henry Poincare in 1905 that electromagnetic force alone cannot explain the electron stability, so he had to introduce another ad hoc hypothesis on electric binding force that ensured the electron's stability, and give a dynamic explanation for the length contraction and thus hide the motions of the stationary ether. Eventually, Albert Einstein in 1905 was the first to completely remove the ad hoc character from the contraction hypothesis by demonstrating that this contraction did not require motion though supposed ether but could be explained using special relativity, which changed our notions of space, time, and simultaneity. Hermann Hermann Minkowski, who demonstrated the geometrical interpretations of all the relativistic effects by introducing his concept of four-dimensional space-time. So this was the history of length contraction, and let us discuss the history of time dilation. The time dilation by the Lorentz factor was predicted by the several authors at the turn of 20th century. Joseph Larmor in 1897 at least of electron orbiting a nucleus wrote individual electrons describing the corresponding part of three orbits in time shorter for the rest system in the ratio under root 1 minus b square by c square. Emil Kohn 1904 specially related this formula to the rate of clock in the context of special relativity. It was shown by the Albert Einstein in 1905 that this effect concerned the nature itself, nature time itself, and he was also the first to point out its reciprocity of symmetry. Subsequently, Hermann Minkowski in 1907 introduced the concept of proper time, which further clarified the meaning of time dilation. So moving on introduction part, so let us understand what is length contraction. So the length contraction is the phenomena of degrees in the length measured by the observer of an object which is traveling at any non-zero velocity relative to the observer. So uh, length contraction is a concept discussed under the theory of relativity. This can be explained using the special theory of relativity of case of understanding. To understand the length contraction and the time dilation, a student must have the background knowledge in the special theory of relativity. The special theory of relativity only deals with the initial frame. Although we cannot even remotely understand the special theory of relativity in a few lines of explanation, there are useful concepts that can be helpful in describing the length contraction and time dilation. The fundamental of a special relativity is that no object that are moving in an initial frame can have the relative velocity greater than the speed of light. The term y, which is equal to the square root of 1 by 1 minus v square by c square, tends to infinity when v tends to c, where v is equal to velocity and c is equal to speed of light, and tends to 1 when v is extremely small compared to c. The length contraction arises from the Lorentz transformation equation. The proper length of an object is the length measured in a frame which is still with respect to the object. The improper length is always smaller than or equal to the proper length. The relationship between these two is given by the improper length, which is equal to proper length by y. When the relative velocity is negligible compared to the speed of light, y tends to 1 and the proper and the improper length becomes the same. So, moving on next, and what is time dilation? The proper time is defined as the time measured by an observer who is not moving relative to that event. The improper time is the time measured by an observer who is moving with a relative velocity v from or to the event. Using the Lorentz transformation equation, it can be shown that the time measured in event frame is always smaller than or equal to the time measured by a moving frame. Thereby, the proper time is smaller than or between the proper time and the improper time is given by improper time interval equals to y dash proper time interval. Since y tends to 1 when the velocity is negligible with respect to the c. So the time dilation effect lead to the famous twin paradox of special relativity. Let us consider a hypothetical experiment involving the twin sisters Sita and Geeta. Since the Sita and Geeta were twins, Geeta decided to travel a universe at a very high speed, similar as speed of light, and Sita decided to stay on Earth. So after the 20th birthday, when Geeta returned to the Earth, she observed that she is much older. Sita is much older than Geeta. So this is due to the time dilation. So if we travel, how this happens? If we travel with a high velocity with respect to another reference frame, then the time of the moving frame is dilated with respect to the another frame. So that's how this looks like. These are the examples. So let's moving on next, and difference between the time dilation and length contraction. So time dilation is an expansion of the time measured from the moving frame, but the length contraction is a contraction of the length. The term gamma connects linear to the time formula but connects inversely to the length formula. So moving on next now, a length contraction. There is a two figure uh, in fixed frame, another is moving frame. So the length contracts, the length of any object in a moving frame will appear for shortened in the direction of the motion of concentrated, and the account of contractions can be calculated from the Lorentz transformation, and the length is maximum in the frame in which the object is at rest. If the length L0 is equal to x2 dash minus x1 dash is measuring in the moving reference frame, then L is equal to L2 minus L1 can be calculated using the Lorentz transformation. But since the two measurements made in the fixed frame are made simultaneously in the frame, T2 is equal to T1, and the equation became like this. And this okay, and this term and this term became 0 and remain x2 minus x1. So x2, since x2 minus x1 is equal to L, so we can find that L is equal to L0 minus something. Now moving on, time dilation. A clock in a moving frame will be seen to be running slow or dilated, and this one is clock. According to the Lorentz transformation, the time will always be shortest as measured in its rest frame. The time measured in the frame in which the clock is at rest is called the proper time. If the time interval T0 is equal to T2 dash minus T1 dash, is measured in the moving frame reference frame, then t is equal to t2 minus t1 can be calculated using Lorentz transformation. And the time measurements made in the moving frame, the time measured in the frame are made at the same location, so the expansion reduces to this. And since and this term becomes zero, as I shown in here as I show in here, and remain this term and t2 dash minus t1 dash, and which is equal to t naught. So the equation becomes like this. And since I didn't mention here, but since 1 by under root this term 1 minus b square by c square, which is equal to gamma, and we replace it by 1 by this term with gamma, so t becomes t naught by gamma. So this term equation became this. And next, for small velocity at which the relativity factor is very close to 1, then the time in dilation can be explained in a binomial expansion to get the approximate expansion. So the equation became like this. And so through this we can find the velocity time dilation. So with this much for today. Thanks for watching.